All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna be doing more, more Hugging Face Transformers, and probably mostly a Yap sesh. I'm not sure what direction it's gonna go in. Let's see what the situation is. I was supposed to stream, but the past couple of days, things happened, and so I just wasn't able to stream. And I'm also streaming at a different time of the day today, but I'm glad that I got the chance to stream at this time of the day. Um, yeah, yeah. So I was supposed to finish off this. Where is it? Let me open that up. Yeah, I was supposed to finish off this quick tour section. I'd said that in the last stream, which I believe was maybe 3 days ago, I think. Um, but I didn't do that because I got busy with something else that was equally as important and needed my time. Actually, hold on, give me a second. Yeah, okay. Yeah. Something that was equally as important and needed my time. Also, you know what? Um I realized I think yesterday or the day before yesterday, and I also remembered today before starting the stream that I haven't been uploading my stream VODs to the stream channel. At least no, not the stream channel, the VODs channel, which I have over on YouTube. At least the ones from November, I think. I think everything from October has been uploaded, but from November it hasn't been uploaded yet. So I need to get around to doing that. Let me just check how many I have. Uh, so fortunately, I date these VODs. Yeah, okay. So including today's VOD, it's gonna be three VODs. I don't know if I've uploaded the very last VOD from last month. Sorry, I'm gonna have to check, and if I haven't uploaded that, then I need to download that and upload it. Uh, but yeah, yeah. Okay, so I've been busy, dude. I've been busy. I've been doing a ton of research, AI research, data science research. Um, I've been looking into a bunch of different things. Dude, I want to get into diffusion related models somehow. I haven't gotten into it yet. I want to approach it from two sides. One is through Hugging Face Transformers. Actually, I think they have a diffusers library for that. I'm not sure what the details are surrounding that. Um, but you know what? Okay, we can check. We can find out now instead of just guessing. We can go and find out what diffusers actually does. Because I'd been meaning to look into diffusers as well. Oh shit! Okay, never mind. Let's go back and okay, great, awesome. So, what are we looking at here? Okay, diffusers is the go-to library for state-of-the-art pre-trained diffusion models for generating images, audio, and even 3D structures of molecules. Whether you're looking for a simple inference solution or you want to train your own model, your own diffusion model, diffusers is a modular toolbox that supports both. Our library is designed with a focus on usability over performance. Wait, usability over performance, simple over easy, and customizability over abstractions. Okay, okay. I like that philosophy. Um, I don't think the lack of performance is really going to be that much of a bad thing right now, because at least when I'm being introduced to the models, when I'm exploring the models, then I don't think it's really a bad thing. Okay, so this is one way that I want to approach diffusion related models. Another way that I want to approach it is trying to implement the architecture myself, or basically building the architecture from scratch myself using PyTorch. Well, building the architecture from scratch to whatever extent possible, like from scratch to whatever extent possible. What I mean by that is quite often when you're working with neural networks, when you're building neural networks, you're you're not always implementing every single thing from scratch. There are often times where you're going to be using pre-made architectures that have been tried and tested, architectures that are meant to sort of be plugged into other architectures. So you're not always building every single thing from scratch. There are a lot of times where you're using blocks that have been made for you to add into your architecture, blocks that are meant to make your work easier. So yeah, to whatever extent I'm able to do it from scratch, I want to do it from scratch. I'm obviously not trying to implement every single thing from scratch, but I do want to. Basically, my point is I want to get into building my own diffusion models. This has always been an interest, well, always ever since stable diffusion was a thing. This has been an interest of mine. Though back when stable diffusion was a thing, I didn't know anything about. Actually, dude, now that I think about it, I'm super happy with the progress that I've made because okay, stable diffusion. I'm trying to think back to when I had started looking into it more. I think it started to explode more around the time that ChatGPT kind of became public. I think that was yeah. I think it was around that time. It did exist before that. I don't know what its situation was in terms of like how available it was to the public before that, but I'm pretty sure it existed before that as well. There was some kind of stable diffusion model, and then later on they came out with other versions. There's stable diffusion 2, and I think there's an XL. I don't know if that's supposed to be better than 2 or if that's just it's meant to do something different. I don't know. I'm going to look into that later. But where was I going with this? Why was I saying this? Yeah. So I'm happy with the progress that I've made in terms of learning machine learning, deep learning, and data science in general. Because back then, I didn't fully understand a whole lot of what was going on. I didn't even know what weights were, weights and biases. To be fair, I still don't fully understand the concept with biases. Like, I haven't understood mathematically how they change things. So I need to do my experiments, my own little experiments to understand that. But I have understood the concept of weights. At least with very basic feed forward neural networks, I've understood the concept of weights. So to me, that's some progress. And it's a lot more progress than, you know, back then where I didn't really know anything. Back then I was approaching these things as basically the end user. A lot of people that would be using these models, be it some kind of LLM or be it some kind of diffusion model, be it stable diffusion or whatever model Midjourney was using. A lot of people, they were more focused on actually creating content with these tools and not really creating the tools themselves. And I'm not saying that's a bad thing. I'm saying that I didn't want to approach it from that way. I actually wanted to learn how these things work, and now I'm slowly making progress in that. I'm actually getting there. Now I don't know when I'm gonna get to this diffusers thing because we still have, dude. I after that day where where I got raided by encoders, um, I don't think I touched neural networks after that. That me not touching neural networks doesn't have anything to do with them raiding me. That's just how I remember it. Like they had raided me on that day. That was the very first time I'd built my first neural network, and it just so happened that after that I kind of got distracted with a bunch of other data science related stuff, so I didn't get a chance to come back to neural networks. And now dude, I want to get back to it because I need to explore. Dude, neural networks are such an interesting concept. When you think about it from a mathematical and a data science point of view, it's kind of interesting how you are able to provide. How do I? Okay, let me think for a second so I can word this properly. What am I trying to say? What I find interesting about at least feed forward neural networks, and I'm pretty sure to a certain extent that's the case with convolutional neural networks and recurrent neural networks and the more complex architectures as well. But I'm going to talk about feed forward neural networks specifically. What I find really interesting about it is that you are able to give it data, you are able to give it variables, and you are able to make it learn a relationship between those variables through training. Those variables can be anything. So the neural network isn't limited to just classifying things. Just for example, it's not limited to just classifying things. You can use it for anything. And this 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 realization, as simple as the realization is, it still kind of blew my mind. Even when I learned this about what do you call it, linear regression. There you go. For some reason, I wasn't able to remember it. Yeah, even back when I properly understood what linear regression is and what exactly is going on when you are doing linear regression, when you're using the linear regression algorithm, when once I had understood how the algorithm works, it became clear to me that the whole idea is to model a linear relationship between the independent and the dependent variables. And while that can be used for prediction and classification, it can also be used for other things. There are a lot of other use cases that you can have for that kind of thing. One use case that immediately came to my mind was creating specific mappings, because you're able to present. Okay, I have this picture in my head, but I'm not sure how well I'm gonna explain it. I'm gonna try and explain it. So you are able to essentially create a model that contains patterns, and each of these patterns describes how various independent variables are connected to a dependent. Wait, did I call the other variables independent? Either way, I don't remember. I said it like 5 seconds ago and I forgot. Yeah, it models a relationship between. Shit, I forgot what I was saying. Let me restart that. So with linear regression, I had it was a nice train of thought that was going on, and I just lost it. With linear regression, the point is, with linear regression, I learned this thing where you are able to model you are able to model a linear relationship between independent and dependent variables, and that relationship can be visualized as patterns. But what's interesting is that you are able to represent these patterns in the form of numbers. And you are able to actually run these numbers through an algorithm to get a result. I guess it kind of comes under classification. The specific use case that I thought about, it's not a very specific use case, but it's one example that had come to my mind when I was thinking of like, oh, hey, how can this be used in different ways? Because when I'm learning data science related stuff, I often find it helpful to just try and plug in different types of examples, be it real world or just silly examples. Like sometimes the kinds of numbers that you might plug into a model, they might not even make sense in the real world. They don't model anything anything real lifelike. They're just random patterns or maybe even just noise. But sometimes I find it helpful to even plug these kinds of random things into a model and see how it behaves. Dude, okay, I need to make a I need to make a TikTok about this, or just a video in general about this, after I've done a little more reading. So, scikit-learn has it has like one section of it, um, which gives the wording for that just got so butchered. What was I trying to say? Scikit-learn has a bunch of data science related tools, bunch of data science and stats related tools. Some of the tools are very useful, or rather, I should say, it also provides you with tools for pre-processing data. And one type of pre-processing is standardizing and normalizing data, or even remapping data. And I used the standard scaler. I can actually show it to you over here. Hold on. I have in the notebook because, dude, I found this incredibly interesting. Hold on. I think I have the thing open here. Or maybe that was in another notebook. Yeah, don't mind this thing. Let me just clear this. I was looking into the os.walk function, and I've never used it. I've seen it being used in the in whatever Kaggle notebooks I make. It's right at the top here. It runs through all the directories in the input folder. So you can get all of your, like, if you've added data sets, you can get an entire list of all of the files along with the folders they're in and the entire path, the entire like breadcrumb, the entire thing gets printed out. And for that, it uses os.walk. And I've never used this function. But once I looked into it, I was like, holy shit, I actually have a use case for this. Because a while back, this was probably a year or two back, I was trying to create a backup program for myself. A program that would back up a bunch of things, including my Unity projects, because I have certain Unity projects that are not throwaway projects. They're like proper projects, active projects, or even fully finished projects that aren't meant to be thrown away. They're supposed to be backed up, whether I'm still working on them or not. And there are some that I'm still working on. For example, my VTuber model, right? Well, my VTuber app. So I need to. I have the Unity projects, or how do I say this? The working projects. Let's call them working projects, not throwaway projects. I've kept the throwaway projects in like a different folder, so I know I'm not supposed to back up any of those projects. But the main ones, which I know I'm going to be working on, or I know they're meant for serious projects, those folders, they go into a different folder, or those projects get organized into a different folder. So I know that I'm supposed to back up that folder. Now the problem is, dude, Unity creates a lot of files. Dude, a lot of files. It's in the tens of thousands, if not hundreds of thousands. I don't know if if it's hundreds of thousands, but it's definitely in the tens of thousands. It is insane. It is crazy. That library folder it goes crazy, dude. Like if you leave that shit for a while, it's gonna not only does it accumulate a lot of files, but the size also grows in the GBs. It's crazy. And my current hard drive, my current system in general, it doesn't do so well with reading and writing files. Let me just put it that way, or rather, copying. I should say copying files. Because I mean, okay, the copying operation is basically reading a file and writing it, right? Though actually, no, I don't know if internally or behind the scenes the OS is handling it in a different way. So I can't say that for sure. But okay, for the sake of simplicity, let's just say it's reading a file and copying it to a different file, right? It's reading the bytes from one file and copying it into a different file. That operation, the copy operation, if you have hundreds of files or thousands of files, computers these days they should be able to do it pretty quickly, right? My system is a little older, and that wouldn't be a problem if I didn't have this hard drive issue. You know, the issue where my hard drive is so slow that it has issues with copying. So when there's situations where there's hundreds of files, I know I'm gonna have to wait for a while for that shit to completely finish copying. And that becomes a nightmare when I have to back up Unity projects along with the library folder. Now, the good news is you don't have to do that. You don't have to back up a project with the library folder. In fact, within a Unity project folder, there are a couple of folders that are redundant, as in they're not required if you're making a backup, because Unity just recreates them when they're not there. And what I wanted to do is I wanted to write a program. Initially, I was going to do it in PowerShell, but now I think I'm just going to do it in Python because setting up more complex logic, it's a lot easier and a lot more comfortable, I should say, in Python than it is in PowerShell, because I've done shit in PowerShell before. So personally I prefer doing it in Python because it's just so much faster. You can do quick and dirty coding with Python. Now, where was I? I was saying something about the Unity projects. I forgot where exactly I was, but I'm just going to continue with the backup thing. So I was going to write a script that when I run it, it creates a backup of all of the specific locations that I specify, right? The specific folders that I specify. The thing is, certain projects, and I'm okay. Another thing is that I don't just do Unity stuff. I do stuff in multiple programs, right? I've got stuff going on in Unity. I've got stuff going on in Blender. Definitely, I have stuff going on in Blender. I've got certain Krita projects. I've got certain at this point I've even got Reaper projects. Is it Reaper? Shit, I haven't touched that program in a bit, and I forgot what it's called. Give me a second. Let me just look at my desktop. Yeah, yeah, Reaper. I've got a couple of Reaper projects as well. Um, I've got I've got a couple of other like Krita projects. So certain projects I have, like for example, VR Chat World projects. Those folders contain multiple different types of projects. They contain Krita projects. They contain obviously the Unity project. It's one Unity project. They contain the Unity project, one or more Blender projects, one or more Krita projects, and then anything else that might be required. So certain projects they actually comprise of multiple different softwares or certain projects comprise of folders or sub projects. I should say that sub projects from different programs. So I can't really write a one size fits all kind of solution. What I wanted to do was, because I have this issue specifically with Unity projects and not with anything else. Specifically for Unity projects, I wanted to write some logic for the program to be able to recognize that it is currently looking through. So okay, the idea is that it's going to run through the script is going to run through the root folder, the root projects folder, which is a folder where I have all of my serious projects, and then in there it's gonna sort of crawl through all of the subfolders, and it's gonna look for different types of projects. Initially, an idea that I had was maintaining a list of projects that I have to back up, and then I could write specific rules for specific projects, right? But then over time, that's going to become very hard to maintain. Scaling wise, it's horrible. That solution does not scale very well. And once my number of projects goes beyond, let's say, 50, it's going to be, forget about 50. Once my number of projects goes beyond 25, I think at this point it's already beyond 25, because I've been doing like a bunch of different things, right? But let's say once the amount crosses, okay, we can go with 50 for the sake of, giving a number that's, I was about to say high enough but also low enough, but then like saying that doesn't really make sense. Okay, for the sake of giving a number, once the number of projects crosses 50, then manually maintaining a list of all the projects that have to be backed up, it just doesn't work. Like it's going to be incredibly tedious. It's going to be very error prone. Hey, give me a second. I will be back. Give me a second. Okay. Sorry about that. I had to step away for a couple of minutes, but I'm back now. Okay. All right. So, oh shit. I just came back and now there's going to be an ad playing in like 30 seconds. My timing is horrible. Okay. What was I talking about? Man, I've been streaming for half an hour and so far, I mean, okay, to be fair, it's supposed to be a mixture of a Yap sesh and Transformers. Oh, yeah, I was talking about my backup program that I was working on, that I was going to start working on. So now that I know, actually, I wonder if I should wait until the ad starts and then I'll yeah, I wonder if I should wait until the ad starts and then I'll continue talking about the backup program. It should be starting any moment now, and there it is. So there's an ad playing right now. I'll see you guys in 30 seconds. I'm going to take a hydration break in the meantime. All right, we are back. Welcome back. So, um, what was I saying? Backup program. Yes. So, a while back, I wanted to make this program, but I never really went all the way with it. So the whole idea. Give me a second. Sorry about this. Give me a second once again. I will be right back. All right. Sorry about that. Something came up, and so I had to temporarily mute. Now, usually, I like to just download my entire VOD. Wait, something's wrong with the audio levels. Give me a second. Check, check, testing, test. Okay. All right, whatever. Okay. So yeah, usually I like to download my VODs and upload them directly without doing any editing. Mostly because editing is kind of a hassle because I'm gonna have to import it into the program, and then making the jump cuts is not really a problem. It's a few small edits, but then I have to export the program, and then I can upload it. No, did I say export the program? No, I have to export the video from the program, and then I can upload it. And exporting a video that is, I don't know, um, what was I saying? Oh yeah, exporting a video that is an hour and a half or 2.5 hours long, that takes some time. So that's why it's a bit of a hassle. So I usually try to avoid it. But today in it, I wanna upload this stream, right? I don't wanna just not upload this stream. So I'm gonna edit the thing just to remove the BRB portions, the dead air portions, basically. All right. So before I continue, I'm gonna finish what I was saying about the backup program because I feel like I kept on branching out and then I kept on losing track of what I was saying. So the idea is I have one folder that I've made in which I've kept all of my serious projects. These might be these might be projects that I have that I'm doing for someone, or projects that I'm doing for myself. Some might be commercial projects, some might be my open source projects. Some projects are projects like VR chat worlds, for example. I don't know if that came through on stream, but like my one of my Linux machines, it keeps asking me to upgrade to the newer version. Um, I'll do it eventually, but like I'm just holding off on it for now. Okay, so yeah, there's all sorts of different projects. The point is like that specific folder contains my serious projects, the projects that actually mean something to me, and they're not scratch projects or throwaway projects. And there are different types of projects. Some of the projects contain sub projects, like little. Some of the projects contain projects from multiple programs because multiple programs are used in the creation of those projects, right? So, of all of the different types of projects that I have, one of the types is Unity. I have other types as well, like Blender, Krita, and now recently Reaper, and a couple of others. Of all of the different types of projects, the one that I need to add custom logic for is Unity specifically, because Unity projects have an insane number of files. More specifically, the library folder that gets created, it over time accumulates a lot of files. Not only does it become bigger in size, but it's also the number of files in it that's just insane. And my system is, or rather my hard drive is not able to copy them fast enough. So even copying one project, it takes a while. And that's, dude, if I'm trying to copy like 10, 20 Unity projects, it's I'm probably gonna have to wait for an entire day, and that's just dumb. So what I want to do is I want to write custom logic to detect. Um, I don't think the word custom really makes sense here. Does it? It's my own program. The whole thing is custom. Either way, I want to write. I want to write custom logic for the Unity programs, for the Unity projects specifically. I want to be able to detect Unity projects, and whenever a Unity project is detected, I want to make sure that all but specific folders get copied. So basically, I want to copy everything from the project except for specific folders like library, OBJ, and a couple of others as well. These specific folders, they you don't need to copy them when you're copying the project because Unity just remakes those folders for you. Of course, if you delete them, then in your project there's going to be a bunch of like re-importing and a bunch of re stuff happening. Either it's re-importing or re-downloading or re whatever, right? But yeah, you don't need to copy these folders. So I want to write logic to detect when we have found a specific Unity project, or well, or detect when the folder that we are currently crawling through is a Unity project. If it is, then I want to write special rules to specifically ignore certain folders while copying all of the other files and folders in that project. And doing this is going to significantly speed up my backup process because aside from that, aside from that, the backup process is going to be pretty quick. It's still going to have to copy a bunch of files and folders, so it's still going to take a while, but it's not going to be nearly as insane as it would have been where each Unity project has like tens of thousands of files. So I should be good. At some point, I'm gonna sit down and write the logic for that, so that I can have periodical or periodic. I think periodical. Periodic probably means something else. Basically, I can have backups every now and then of my projects. The whole idea behind putting those projects into that one folder was that I have one folder that I know I absolutely need to back it up. If everything else on the hard drive becomes unreadable, perfectly fine. That specific folder should never become unreadable because those are very important projects. That's why I created that folder. And so I know that entire folder has to be copied. But in that folder, any Unity projects that reside, I need to make sure I'm not copying the library folder and the OBJ folder and a bunch of other useless folders from the project. So that way I can speed up the backup process. And another thing that I would like to do, I'm gonna have to see how to go about doing this. I'm sure there's a library to to help me do it, but I need to also create a zip file out of that entire folder. So I'm gonna have to see how to go about setting that up. I don't know yet, but yeah, okay. So keeping my temporary mute segment of this stream and keeping my BRB segments aside, I think we've been yapping for about 45 minutes. Dude, I kind of want to do this. I kind of want to make it a thing where I just have a yap session for a while. And while I'm having a yap session, I want to have different overlays for my stream. So first of all, I want to set up a kind of thing where it looks like there's these two windows that are currently being captured. I want it to look like there's two. I want it to look like there's two monitors or something there, or two holographic image kind of things. I'm gonna have to see how to go about setting that whole thing up. But yeah, I want to set up something like that. I want to set up a thing for just chatting, even though I'm not gonna be in just chatting. I'm just gonna do my Yap sesh in software and game development category, but it's still just chatting. I've just been chatting most of this time. So yeah, I wanna have a separate thing for just chatting, and then I want to have a separate thing for uh, when I'm actually, studying and working on stuff, like once we actually get into the studies. The thing is, I don't know if I really need a separate thing. Like if I did have a separate thing, it would be just for the sake of having it. Because usually when I'm yapping about stuff, I I kind of like having the extra screens around so that if I want to show you guys something, I can show it to you easily. But on the other hand, if I did a separate just chatting scene, I feel like that could have its own benefits as well. Yeah, I feel like that could have its own benefits as well. It could, because I could introduce more things, more moving parts. I mean, even here, I'm going to be introducing more moving parts into this scene as well. But like in that scene, I could introduce more moving parts, and once my model has more detailing in it, that's whenever I get around to doing it. Once it has more detailing in it, I can then I can have it as like, a bigger version. I would kind of want it to be a bigger version as well. And that's okay. That's another thing in the just chatting. If I did create like a separate just chatting scene, a separate just chatting overlay, my model would be bigger on screen, and I would be showing chat on like one side of the scene, of the screen, the scene, one side of the scene. Though I don't really think I'm gonna be using the just chatting scene a whole lot because well, I mean, I'm a pretty small streamer right now. It's not like I have a whole bunch of people chatting. So I don't think I need to rush with the just chatting overlay. I can stick with this, and I can work on adding details to this current setup that I have going on. I also have like these logos on the right side. I need to make sure that I'm not doing anything to like occlude the logos, because I kind of want to show. I kind of like having the logos there. I'm not affiliated with any of them, by the way. It's just I like to have the logos of things that I'm currently using. I like to have the logos of them on the screen if possible. So currently I'm doing stuff with Kaggle notebooks. So I've put Kaggle there. I'm using HuggingFace Transformers. So I put the Transformers logo there. And I'm doing Python. So I put the Python logo there. So it kind of gives people an idea of what exactly is going on, even though, well, not exactly, but it gives them a brief idea of what we are doing, what's being it gives them a brief idea of what might be going on here. That is assuming people know about Kaggle and about transformers, and assuming people know that that logo down there is a Python logo. Because to be honest, like if I was looking at these logos, I wouldn't my mind wouldn't like immediately connect these logos to the brands or to the whatever trademark or whatever you want to call them. My mind wouldn't immediately connect it, but like maybe other people's minds connects it. I don't know. Okay, so we are going to carry on with the quick tour section. I was supposed to finish this. I had said in the last stream that I would be finishing this off stream, but like I mentioned, give me a second. But like I mentioned, things happened. I got busy, and so I couldn't do it. So we're gonna finish this. We're gonna finish this. Dude. I'm trying to equally give my time to data science through scikit-learn, neural networks, making neural networks in PyTorch, and learning about the Transformers library. quick thing before we carry on with this, one last, I'm saying it's the last detour, but like I don't know if it's going to be the last one, because knowing my mind, there's probably going to be a bunch of other distractions and detours and shit. So I've been seeing this thing popping up a bunch. I'm just going to open this up to show you guys. Let me, I mean, I guess I can also open up the, oh, I don't know if the website is going to cause my stream to lag in some way, silly as that may sound. Actually, I want to show you guys, wait, can I show you guys the images through this? They have an images section. They actually have an example section, which is, I believe it is on the website. Okay, yeah, so I'm going to show you guys. Let me just transition back. Okay, here's the thing, right? Okay, so there's this thing that has been popping up in my Twitter feed. A bunch of people that use various types of image generation and video generation and audio generation models. A bunch of people that experiment with these a lot. They have been using this thing called Comfy UI. And I found this interesting because this is a node-based editor that lets you create a node-based workflow. Obviously, node-based editor. It lets you create a node, at least from my understanding, it lets you create a node-based workflow to uh, sort of chain the inputs and outputs of multiple models together. That's what I've gotten so far. Let's read the description again. They also have a website where you can see a bunch of examples of stuff that uh, where okay they had an example section. Let me show you the example section for, is it under docs? Why is docs not clickable? Docs was clickable, but for some reason it didn't change the cursor for me. Where are the examples? I still don't know. I know like nothing about this, but I do want to explore this at some point to see what's possible with it. Because I feel like something like this can be very useful. I don't know to what extent you are able to use other models with this. I don't know if it's only if it's limited to um, specific types of models or um, specific model architectures or what. I don't know what the situation is with it. I'm gonna have to explore this this thing more. But the point is, I do want to explore this more because I feel like setting up a node based workflow um, for generative AI, it can be incredibly helpful, especially when you talk about something like, image generation or video generation or even audio generation for that matter. But I'm talking about image and video specifically, because quite often there's a bunch of different models involved in trying to get something done. Different models might be handling different things, and the output of one model gets used as the input to another model, and you basically need all of these different um, different moving blocks. You need a lot of you need all of these different moving blocks put together in order to get the result that you're looking for. And I feel like setting up a node-based workflow to do something like that can be incredibly helpful for, especially for people who don't do a whole lot of coding. Because right now, a lot of people who are trying to chain stuff together, a lot of people who want to create something custom, they would have to do it through Python using a bunch of the different libraries, right? So Hugging Face, if you want to do more higher level stuff or a lot more complex stuff, or PyTorch, if you want to do a lot more custom and definitely a lot more complex stuff, but more emphasis on custom. Because like if you're trying to create your own custom architecture, then yes, you would be using something like PyTorch or TensorFlow or Keras or whatever other thing is there. Where was I going with this? Yeah. So my point is, and I kind of I'm looking at this from like the shader point of view because I'm big into shaders. I used to do a lot of shader coding a while back, but these days I don't play around with it too much because I've been messing around with a bunch of other stuff. I do try to revisit VFX whenever I can, but I don't do too much of it these days. But over the years, through my experience in both coding shaders and using node-based workflows, I can tell you node-based workflows are incredibly helpful. They are incredibly helpful specifically for VFX related stuff because they allow you to create blocks and then sort of visualize what the entire workflow is going to be like as opposed to writing the entire shader in code, which I mean to a certain extent visualization is possible there as well, but it's not nearly as good as node based workflows. On the other hand, if you're doing something incredibly complex, like if you're writing a complex compute shader or something like that, yeah, you definitely want to write that in code and not do it through node-based workflows because node-based workflows are horrible when it comes to setting up incredibly complex algorithms. Or rather, I should say they're not horrible necessarily, but if they give you the option to if they give you the option to create subgraphs or subnodes out of a group of nodes, and more importantly if they give you the option to create custom nodes where you can write your own block of code, then that node based workflow is incredibly powerful because those kinds of workflows, they give you the best of both worlds. They give you the ability to write custom code where you need to. If there's like some complex math algorithm that you don't want to, create hundreds of nodes to set up, you can just write it out as a custom node, as a custom block of code, and then that can be part of a custom node, and that custom node can be used as sort of a function within your bigger graph where you have set up a much more complex simulation through the node based workflow. Okay, enough with shader stuff. My point is, this is I feel like this is something like this is important. I don't know how well it performs. I still need to explore this a lot more. I don't know what the limitations are, but I do want to explore this more because having something like this, I do hope more people make stuff like this because having something like this can be incredibly useful. And it doesn't have to be specifically for generative AI. It doesn't have to be specifically for, generating artwork or generating videos or even generating audio for that matter. It can be for something else, but like being able to set up a node-based workflow it's super important, especially when you consider that a lot of times people are using pre-trained models, pre-built and pre-trained models. So all they would have to do is just plug in the model into the node graph, and then they have something incredibly powerful there. I don't know how well it performs, but it's something incredibly powerful. So yeah, I do wanna explore this at some point in the future. Now, let's get back to this thing. So we were at the tokenizer section. Give me a second. Let me hydrate and then I'll carry on reading. All right. Okay. So, let's run through this real quick. I believe I've done this. I just want to run through this until we reach to the auto part. Okay, so start by creating an instance of pipeline and specifying a task you want to use it for. I've done this already. Okay, okay. Pre-trained model, we pass in the input. Okay, there's a high level way of doing it and a somewhat low level, but not really low level. It's just a slightly more customized way of doing it as well. So the high level way is you create the pipeline object, and then you can call that pipeline object as a function where you pass in the input and pipeline just handles everything else for you, or whatever the underlying abstraction is, it handles everything for you, depending on what your task is and which model is being used and stuff like that. So that's one way, that's a high level way. And then there's a slightly low level way, which isn't necessarily low level, but it's a more customizable option where you get to specify the working parts of that specific task, and you get to customize how the input is passed from one part to another, and then to another, and then to another. But of course you need to know everything about that architecture and how things are supposed to be done. Give me a second. Okay, what was I saying? Yeah, you need to know everything about the moving parts of that architecture and what you're going to need, like what what input needs to be passed to which specific moving part. um yeah, yeah. So you need to know something about that architecture in order to be able to do it in a custom way, but you do have the option. That's the point. Okay, so then we move on to this thing. This was the audio example. Okay, I remember I was mentioning that I want to I want to fine tune a speech recognition model on my voice samples. Dude, you know what I could do? Yo, I just got an idea. So I could, dude, I could create. Okay, so I'm planning on creating. So, okay, if I'm going to be fine tuning a speech recognition model on my own data, that data is going to have to contain my voice samples, right? And I'm gonna have to be saying specific things, and then those things get classified as stuff. I still don't know how to go about setting up that kind of data set, but once I have set up that kind of data set, I could provide that on Kaggle for free. I just got that idea, dude. Yeah, dude, that could work. That could work because then people who have my specific kind of vocabulary and my kind of accent and my kind of voice, they could then use this to train their own models, or they could use this to fine tune their own models. I'm sure. Okay, I'm probably not the first person to have this idea, right? I'm definitely not the first person to have this idea, but I feel like when we're talking about fine tuning, it's like a it's never a one size fits all solution. That's the whole point, because that one size doesn't fit all. So you kind of need a custom thing, right? So I feel like even if a bunch of other people have done it, I mean, I'm going to upload it regardless, whether a bunch of other people have done it or not. Because I'm going to upload it because I want to. But I feel like when it comes to voices, fine tuning on different data sets will have different results. Especially because, when it comes to speech, not everyone speaks the same way. Not everyone has the same accent. Not everyone has the same pronunciation, the same way of forming sentences, the same voice. And like there's a bunch of different things, speech patterns, I guess. There's a bunch of different variables there that could be different. Yeah, dude, I'm getting ideas. I'm getting ideas now. I need to get to that fine tuning stage quickly. By the way, the fine tuning stage that I'm talking about is this fine tuning a pre-trained model. I need to look into what pre-processing or what the pre-processed data section contains. Okay, I'm gonna get distracted. I'm wondering if I should read this first, pre-processed data. If I should read this first before um before going into the fine-tuning thing. Yeah, I feel like I should read not just pre-processed data, but I feel like I should read all three of these sections before going to fine-tuning, because fine-tuning the data is in a way not fine-tuning the data, fine-tuning the have I been saying fine-tuning the data all this time? I just realized. No, I don't think I've been saying that. Fine-tuning the model. Either way, I meant fine-tuning the model. So um, fine-tuning the model is in a way kind of training the model. You're not necessarily training it from scratch. You're making like minor changes, but the changes that you're making, they customize the model to your. Actually, okay, I take that back. No, I don't know if fine tuning is in a way training it from scratch, because they wouldn't call it fine tuning then, right? They would just call it training if it was actually training from scratch. Not to mention, dude, you're not training a fucking massive model that has been trained on 10,000 or 20,000 voice samples. You're not going to train that thing from scratch unless you have your own data set with that many samples. You're not going to train that thing from scratch, right? Um, like if we're talking about customizing it to your specific need, you would be fine tuning. Where was I going with this? I feel like I branched out so much that I just forgot where I was. So yeah, okay, I have that idea. Whenever I do prepare the data set for fine tuning my own speech recognition model, then maybe I can uh, post that up on Kaggle. I I'm gonna have to see how big the, what do you call it? What am I trying to say? Yeah, I'm gonna have to see how big the data set ends up being. Because I think they use a low sample rate, because a lower sample rate means, the size is also going to be smaller, because it's a smaller number of samples per second. That does affect quality, but I feel like in that small sample rate, they're still able to capture what they need to capture. They're able to work with that data, because that 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 data that those samples are not necessarily for the human ear to listen. They're for the model to use. So I feel like they're able to get what they need with even that small sample rate. So I can record the stuff in a low sample rate, and that way the data set would end up being smaller. Okay, all right, let's carry on with this. So for this thing, they used auto model for sequence classification and auto tokenizer. Okay, so I've done that already. We are using pre-trained models. I think what we were using is exactly this one. Give me a second. Let me just open that back up. Oh, I think the session has to start again. This is for the LLM. Oh, here it is. Yeah. So this is the exact thing that we were using. Okay. Carrying on, we go down to specify the model and tokenizer in the pipeline, and now you can apply the classifier on French text. Okay. All right. Great. So that's the model. That's the tokenizer. I think. I mean, I'm just revisiting this. I've done this already a couple times actually, and I'm like revisiting it again and again. If you can't find a model for your use case, you'll need to fine-tune a pre-trained model on your data. Take a look at take a look at our fine-tuning tutorial to learn how. Finally, after you've fine-tuned your pre-trained model, please consider sharing the model with the community. Oh yeah, I could do that as well. Please consider sharing the model with the community on the hub to democratize machine learning for everyone. Yes, I'm glad that they mentioned that because that completely slipped my mind. Sharing the pre-trained, not the pre-trained, sharing the fine-tuned pre-trained model on Hugging Face. Um, okay, auto class. Under the hood, the auto model for sequence classification and auto tokenizer classes work together to power the pipeline you used above. An autoclass is a shortcut that automatically retrieves the architecture of a pre-trained model from its name or path. You only need to select the appropriate autoclass for your task and its associated pre-processing class. Okay. Let's return to the example. Let's re- let's return to the example from the previous section and see how you can use the autoclass to replicate the results of the pipeline. Auto tokenizer. A tokenizer is responsible for pre-processing text into an array of numbers as inputs to a model. There are multiple rules that govern the tokenization process, including how to split a word and what and at what level words should be split. Learn more about tokenization and so and so. Okay. The most important thing to remember is you need to instantiate a tokenizer with the same model name to ensure you're using the same tokenization rules a model was pre-trained with. Okay, so that's interesting. That can also have an impact. You can't just plug anything into anything. So so a tokenizer, it it converts words and phrases into numerical representations based on certain rules. And then those numerical representations get passed as inputs to the model itself. But that model has been created keeping these rules in mind. So they are in some way connected with each other. All right, so that's I guess that's important to keep in mind. A good experiment would be to try and plug a different kind of tokenizer into a different model and see what the result is. Um, okay, where was I? Yeah, load a tokenizer with auto tokenizer. Okay. So yeah, I found this interesting, and I mean I've mentioned this before. I'm gonna mention it again. I found this interesting. You are able to specify the model name, and it's gonna download the thing that it needs from that model. It's not. I don't think it's just a model. I think it's like a repo that you're specifying. I mean, we are saying model name, but like I think it's like a collection of things because that same thing contains the tokenizer and the same thing contains the what do you call it? Oh, you know what? I just realized no. So okay, what I was about to say was maybe there's a repo set up with this name and this repo contains the tokenizer and the model, right? So then Transformers knows what to download, and of course it knows where to download it from. But then another thought occurred to me: what if internally Transformers has like a set of rules where it knows, given a certain model name, how to find the tokenizer, and given a certain model name, how to find the model itself? So internally, could it be, how do I find this out? Like where it's getting the tokenizer from? Like, is my first assumption correct, or is there something else going on? Uh, they mentioned Bert base something, right? Is there was a link to the thing? I think it's this one. Yeah, it's this one. So this is the link. If you are able to see, I don't think you can see the address bar, but the address bar just says HTTPS and then the colon slash slash and whatever, huggingface.co/ this NLP town slash whatever this is. The address bar basically says that. Now I'm wondering, where is the tokenizer here and where is the model? Like, how does it know? Okay, so this says model tree. All right. I don't know if this has anything to do with the thing. Right, maybe this is not what I'm looking for. Oh, you know what? Instead of guessing, why don't I just ask Perplexity? Actually, no, why don't I just ask Llama? Give me a second while I load that up. What was it? I think it was labs.perplexity.ai. Okay, I'm learning how to use HF transformers. Uh, I need to phrase this properly. I noticed that. Give me a second. Okay, so dude, you know what? I need to take a short break. Just a quick like 1 minute break. And anyways, in the next 15 seconds, there's going to be an ad playing, so I'm going to start the ad break right now. But I'll be back in like 2 minutes probably. All right, I'm back. So let's ask Llama what we were planning on asking. So I noticed that, no, rather, I'm learning how to use Hugging Face Transformers. I noticed that dude, give me another second. Okay, yeah, I'm good. Uh, what was I saying? Yeah, we were writing this thing, right? So I noticed that dude, I my mind keeps wandering. Holy shit. Okay, I'm learning how to use Hugging Face Transformers. I noticed that um, I am able to pass one model name to the pipeline object, and it will be able to find the tokenizer and the model given that same name. I'm wondering, how is this working? Or how does this work? How does this work? Um, are the tokenizer and model packaged into one repo and hosted on Hugging Face, or are they hosted separately, and the and pipeline somehow knows where to look? This is holy shit. I don't know. I don't know if this is gonna. Okay, you know what? It's doing well. It's doing well. Let's see what the response is. Okay, when using the dude, okay, I'm wondering if this is gonna end up being one of those situations where I should have just kept on reading, and if I would have read a little more, then my question would have been answered, because this shit has happened before. This shit has definitely happened with me before. Okay, so it mentions the tokenizer. Check out the pre-process. Okay, auto model. Okay, Transforms provides a simple, unified way to load pre-trained instances. This means you can load auto model like you would load an auto tokenizer. The only difference is selecting the correct auto model for your task. For text classification, for text or sequence classification, you should load auto model for sequence classification. Okay, all right. Okay, is it mentioning? It says that it provides a unified way. All transformers models output tensors before the final. Okay, yeah, no, that's not what I'm looking for. All right, so this then jumps to save a model. All right, so it doesn't answer the question, or it doesn't clear my doubt. Okay, so when using the Hugging Face Transformers library, the ability to pass a single model name to the pipeline and have it automatically load the corresponding model and tokenizer is facilitated by several key mechanisms. Auto classes. The Transformers library uses auto classes such as auto model, auto tokenizer, and auto feature extractor. These classes automatically load the correct model architecture, tokenizer, and or feature extractor based on the model name provided. For example, if you specify a model name like Bert Base Uncased, um, where where was I? Yeah, the auto model and auto tokenizer classes will load the corresponding pre-trained model tokenizer from the Hugging Face model hub. Model hub. Models, tokenizers, and feature extractors are hosted on Hugging Face Model Hub. Each model repository on the hub typically includes the model weights, configuration files, and the associated tokenizer or feature extractor. When you specify a model name, okay, all right, hold on. Where can I confirm this? Okay, so I don't know. I don't know what the repo is supposed to contain. So though I'm seeing tokenizer config mentioned here, and then there was something else config I'd seen. Um, but this is the model, I'm guessing. And this might be the TensorFlow version, and this might be the Flax version. I I, I know like nothing about Flax. I'm not gonna go into it right now. Um, okay, let's try opening this. Let's see what's in here. That is all that's in here. Okay. Do lowercase true. What about in this? Okay. Oh, this is the model uh this is the model architecture, and also, well, this is the model architecture and I think hyperparameters as well. This is the config file that we have to change when we are trying to train the model. I think even when we are trying to fine tune it, maybe we have to change it then as well. I don't know. Okay, what is well, the README probably just says what was here, but let's open this up and see. Yeah, I think it says the same thing. Okay, so I'm still wondering, where is it getting? Could the tokenizer, could it be that the tokenizer and the model are both packaged into one PyTorch thing here? Like, could that be a possibility? That's interesting. I like that they're doing these scans as well. Okay. Uh, let's carry on. Let's carry on reading. Each model repo on the hub typically includes the model weights, configuration files, and the associated tokenizer or feature extractor. When you specify a model name, the library queries the model hub to download and load the necessary components. Default load behavior. If you do not explicitly specify, no, what? Provide. Oh, if you do not explicitly provide a tokenizer or feature extractor, the pipeline will automatically load the default ones associated with the specified model. This is handled by the pipeline function, which checks the model name and loads the corresponding tokenizer and other necessary components if they are not provided explicitly. Each model on the model hub has a configuration file that specifies the details of the model, including the tokenizer and feature extractor to use. When you load a model using its name, the library reads this configuration file to determine which tokenizer and other components to use. I'm looking at the files, or well, the files section of a model, or maybe I should use the exact name. Uh, there, model, and I'm not seeing a tokenizer. Yet pipeline knows that it has to download a tokenizer. where is the tokenizer being downloaded from if it's not present here? When you use so-and-so model through HuggingFace Transformers library, the tokenizer is not necessarily stored in the same repository as the model weights. Here's how it works. Model hub and auto classes. Oh, you know what? What if I try to search for BERT tokenizer? BERT tokenizer. Wait, this loaded Google BERT. Um, let's see what NLP Town has. So they have two models here. Okay. I'm not seeing a tokenizer. Um, this model is intended for direct use as a sentiment analysis model for product reviews in any of the 6 languages above, or for further fine-tuning on related sentiment analysis. Training data, accuracy. Yeah, it is not mentioning. Okay, let's go back here and see. Uh, when you load a model, where was I? Yeah, okay. The Hugging Face Model Hub hosts models and each model has a corresponding configuration file that specifies the details of the model, including the tokenizer to use. Okay, let's pause real quick and take a look in the configuration file. Maybe I missed something because I just scrolled through the thing quickly, so there's a good chance I missed something. Does it mention? So it mentions architecture here, BERT for sequence classification. Okay, all right. Model type BERT. It is not mentioning the tokenizer. Yeah, I'm not seeing it here. When you load a model using its name, the AutoTokenizer class from the Transformers library queries the model to find and download the appropriate tokenizer associated with that model. Um, the configuration file for the model contains metadata that points to the correct tokenizer. Even if the tokenizer files are not visible in the model repository, the configuration file will direct the library to the correct tokenizer. Okay. Default tokenizers. For pre-trained models, including BERT, there are default tokenizers that are commonly used. For example, BERT Multilingual Uncased. A model typically uses BERT tokenizer, or a variant of it. The Transformers library knows to load the default tokenizer when you specify the model name. Even if the tokenizer files are not explicitly listed in the model's repository. Okay, so there's something called BERT tokenizer. BERT tokenizer. There's a bunch of different BERT tokenizers. Let's just search for BERT tokenizer. So I think they have it for different languages. And then there's just one here that says BERT tokenizer. How do I find out which one Hugging Face is using? Hugging Face? No. Which one Transformers is using? How do I find that out? Um, okay, what about if I did something like this? Wait, did that increase the number of results? That increased the number of results. All right, what if I just do a space? So then, um, okay, so I'm still confused about this, but I think I'll pause it for now and just carry on with the thing. Probably at some point in the future I'll figure out what exactly it's doing. For now, let's just carry on with this. So where were we? Auto tokenizer. Yes. Okay. So let's return to the example from the previous section and see how you can use the auto class to replicate the results of the pipeline. Auto tokenizer. A tokenizer is responsible for pre-processing text into an array. Didn't I read this already? Yeah, the most important thing to remember is that you need to instantiate a tokenizer with the same model name to ensure you're using the same tokenization rules a model was pre-trained with. Okay, so I'm guessing this comes back to making um, making a model or a neural network learn a relationship between variables. The only way that you're able to do that is if you have a fixed set of rules. Like if you know the rules that the text was tokenized on, only then can you properly create, like when you have a fixed set of rules, only then can you properly model a relationship between variables. I need to explore dude, one of these days we need to go back and do the neural network thing again because there's tons of stuff that I want to do. There's tons of experimentation for me to do. There's tons of exploration for me to do in terms of neural networks. Give me a second. Okay, yeah. There's tons of exploration for me to do when it comes to neural networks. And right now with feed forward neural networks alone, I have a bunch of exploration to do. So one of these days I wanna go and do that, or go back to PyTorch and do that. And we also need to move forward with learning about CNNs and RNNs because it doesn't stop there. There's much more complex architectures that I want to learn as well. And the only way that I can learn those complex architectures is if I learn these basic architectures first, because these basic architectures and all the various other um, tools like activation function, nonlinear activation functions, and pooling functions, and all of that stuff. All of these different tools put together, they are what are used to make more complex architectures. So if I'm going to be making complex stuff before that, I kind of want to learn how the basic building blocks work. Um, but yeah, okay. Let's carry on with this. So we load the tokenizer. Okay, then we pass the text. This is what we get in return. Give me a second. Let me go back here. Uh, what was the text? The text was "Hey there," and for that we got this result. Hold on, I'm curious if Kaggle has. Hold on, there was a library which allowed you to do pretty printing. Um, Python pretty print. I don't remember what the library was called. Something to do with cats, I think. It was some kind of cutesy name. I don't remember. Okay, so one thing which is already part of Python is something called pprint or pretty print, which I remember visiting this ages ago and I just completely forgot about it. But this is not what I was looking for. There was another one. I'm just going through Stack Overflow to see if somebody mentions it because it was an open source library and I don't remember the name. Give me a second. Um, all right, there's pretty print. Uh, Simply by unpacking. Nope, that's not what I'm looking for. Though, I mean, it's good to know that I can just unpack the thing. Oh, dude, I forgot about that. Holy shit. Wait, can we also unpack dictionaries? Does that work? Dude, I forgot. Okay, it never occurred to me because like I know that you can use this as an unpacking operator. I think this is also an unpacking operator. But it never occurred to me to use it in this way. I wonder if it works for dictionaries. What about this? Nah, it only works for lists apparently. So A equals this and then wait, really? Oh, that's not the error. Actually, let's go back and run this whole thing. And after this thing is done running, when I run this, it's going to try and download the model again. So we're going to have to wait for a little bit. Okay, is that done? That is done. So let's run this. And once it's done downloading, we should be good. All right, so now there's an issue. Input IDs is an invalid keyword argument for print. Okay, so this makes it a list, but this is not a list. This is a dictionary. Is it going to... Oh, that's interesting. When you unpack this, it unpacks the keys. So if I unpacked... Dude, I've legit never done this. I've never tried to, or but I mean I've done it very rarely, and I've never done it in print. I'll definitely say that. I need to use the unpacking thing a lot more because like it's one of those things that like I read about it at some point, and I learned that yeah, unpacking is a thing, and I've used it in the context of function arguments, function parameters. But then it just never occurred to me to use it outside of that context. And so each time I saw this, I would just kind of associate it with pointers and I would be like, oh, okay, what are they what are they trying to do here? So, okay, if I try to use this, it unpacks the list in that way. Okay, all right, great. So, what was I trying to do? Yeah, I was looking for, okay, back to this. So there's pretty print. Uh, but that's also not what I'm looking for. Dude, there was a library. Somebody had made a library with some very useful features. What was the name of that library, dude? Pretty print library. Okay, it keeps bringing up pprint, which is pretty print. No, dude, there was. I'm not able to remember what the thing was. What was it called, dude? There was a pretty printer. No, that's not it either. Okay, let's take a look at what pretty printer has. Maybe I can open it up here. Okay, data pretty printer. Okay, let's also look up print library GitHub. Was it this? Was it called OBJ print? No, it wasn't called OBJ print. It wasn't rich. Man, I'm not able to remember. I think I'd made a tweet about it. Maybe I can look up my tweets later. Yeah, maybe then I'll find it. Okay, the pprint module provides a capability. The preprint the preprint the pprint module provides a capability to pretty print arbitrary Python data structures in a form which can be used as input to the interpreter. Which can be used as input to the interpreter. If the formatted structures include objects which are not fundamental Python types, the representation may not be loadable. This may be the case if objects such as files, sockets, and classes are included, as well as many other objects which are not representable as Python literals. The formatted representation keeps objects on a single line if it can and breaks them onto multiple lines if they don't fit within the allowed width, adjustable by the width parameter, defaulting to so and so. Dictionaries are sorted by key before the display is computed. All right, let's try that. Wait, what are the functions? Just pp? Okay. All right. Prints the formatted representation of so and so. All right. Let's try importing this. What is it? From p print import pp. My God, dude. Okay. Okay, what's the difference between pp and pretty? My fucking childish humor, dude. Holy shit. Okay, what's the difference between pp and pretty print? Pretty print is a Python object. Pretty print. Wait, no. Pretty print a Python object and pretty print so and so to a stream. I'm not sure. It kind of seems like one is a wrapper around the other. Though in this one, we are able to specify whether dictionaries should be sorted. Okay. All right. Let's try this. Oh, that looks much better, dude. Now that is so much better than this. Yeah, look at that. Yeah, this actually no, this actually helps. This definitely helps. I should keep this in I should keep this in mind. Okay. Um sorry, give me give me a second. Just a minute. All right. Okay. Uh right. So, okay, you know what? Here's what I'm going to do. I need to go eat. So, I could stop the stream here and then restart it again. I mean, I'm going to be like grouping the entire. I mean, I could start up the stream again later and then like stitch this stream and the new stream together and then like make it like one big stream and upload that. That'll work. I'm thinking about the upload thing, but like, I also want to stream later. You know what? Yeah, okay. We're gonna do that. So I'm gonna end the stream here. I'm gonna go eat something and maybe I'll start up the stream in like an hour and a half, something like that. I'll see. I don't know. But yeah, um, I'll I'll catch you guys later. I would do my usual outro thing, which is like, uh, I hope you guys have a nice day and I'll see you all next time and stuff. But like, I'm probably gonna be starting the stream again later. You know what? For now, I guess we are gonna go raid Oz. Uh, Little Witch Oz. Yes, we're gonna go raid Oz. Oz is cool people. Oz is a friend of the channel. Oz is a friend of mine. And uh, what else? Oz is cool people, dude. We're gonna go hang out with Oz. Oz is playing some Final Fantasy. But yeah, I hope you guys have a nice day, and I'll see you all next time, which is probably gonna be again in a short period of time. Let me go eat, and I'll see. I'll start up the stream again later on.